Emission Duration, Segment 3, by Claire Hans and Sean Peterson. The research question of this lab was, what does emission duration depend on and not depend on? While the hypothesis was that emission duration in glow sticks is completely dependent on energy input and completely independent of the emitting fluorescent dye. Emission duration refers to the length of time light is being emitted. This is not directly shown in an emission spectroscopy graph. However, emission spectroscopy can determine if light is still being emitted. If there are peaks that are represented above the baseline, then it can be said light is still being emitted. Emission duration depends both on energy input and the emitting fluorescent dye. Energy and intensity of light emitted are related. As it is seen in the graph, as less activators input into the system, the amount of photons emitted decreased. Because there's not a continuous flow of energy input into the system, eventually the energy will run out, which would result in an inability to excite electrons. The ability of the dye molecules to react to the activator or the energy input will also affect duration. Frequency and wavelength are inversely related, so at longer wavelengths, the frequency at which photons are emitted will be less than that at shorter wavelengths. Red dye has a lambda max at a higher wavelength than green. Because its energy level transitions are smaller than green, the photons are emitted with less energy and less frequency. Therefore, the rate at which the red dye molecules react with the inputted energy is less than that of green. The red dye will be able to absorb energy and emit more photons for a longer duration than green. For example, if one person was throwing a small ball to a partner and the other person was throwing a bigger ball to a different partner, it would require more energy for the person throwing the bigger ball than the person throwing the smaller ball. Eventually, the person throwing the bigger ball will run out of energy required to reach their partner, whereas the person throwing the smaller ball will be able to continue for a longer period of time. This would represent how emission duration is affected by energy input and the composition of the dye molecules. In conclusion, the hypothesis is refuted. Although the energy input affects the duration of emission, the molecular composition of the dye molecule will also affect it. The molecular composition of the dye molecule affects its ability to react to the energy input.